Hi, I'm Brooke Schuit. My student ID is 1101869091. So I'm here to do my evaluation report. My investigation that I completed at my external prac was based on forces. So the class I had was a Year 4 class at Tyndale Christian School, and I was able to conduct the investigation with the whole class. So most of my teaching was whole class based. So as I said, we were focused on force, and according to dictionary.com, a force is an influence that can move or change an object. So when looking at the science curriculum, force can be found in the physical science strand or substrand, and the content descriptor for Year 4 was ACSSU076. Forces can be exerted by an object on another through direct contact or from a distance. So that's what this investigation was framed on. So in terms of prior knowledge, this was part of a unit plan on force. So we'd already done previous lessons on push and pull, magnets, gravity and lift, and a little bit of friction. So they knew of friction, but it's not a big thing to them yet. So as this was part of a unit plan, we didn't need to do a prior lesson on prior knowledge or even have a big chunk in the investigation because we'd already gathered some of their prior knowledge through previous lessons. However, we did start the lesson with a bit of a recap and just some discussion about what they think might happen in that lesson. So students were investigating in particular the question, how does different size forces affect the distance of an object? So that's what they were looking at. And they had set equipment. It was a very controlled investigation. That was due to the setup of the school, the restrictions at the school, and also the students in that class. So there were a few troubled students and a few that needed a lot of support. So making it as controlled as possible, but still letting them have that hands-on was the best way we could go. So other than the prior knowledge of force, students also needed to know how to conduct a fair investigation, how to record data, so like measurements, how to accurately measure, so just making sure they're actually looking at the right point on their ruler. And students need to know a bit about variables and why variables can affect the investigation. And one of the variables that we had was the surface. So some students completed it on carpet, some completed it on a smooth surface. So when we went back and looked, that's where we could differentiate the students who noticed that there was a difference, why was there a difference, and those were the students that showed a bit more application of the theory. So in terms of introducing the investigation, they're engaged through a video. So as you can see in Appendix A on my written report, it's my lesson plan. There was only mention of a video. However, with further discussion with my mentor, we actually implemented the video just to recap. So as I said, it was in the middle of a unit plan. Students only have a double of science once a week. So it had been 7 days since they'd last thought about friction and force and gravity. So this little clip just recapped, brought them back into that science mindset and had them thinking about it again. So not only we did that, we also had a bit of a class discussion of everyday examples. I used some probe questions, and then I did a bit of a demo. So the demo wasn't exactly the investigation they were going to do, but it was basically the same, just different materials. For a Year 4, that's completely different. So I used a foam ball and I had 3 lots of masking tape set out, and I asked the students, if I kick it from this one, do you think it will go further than if I kick it from this one? Obviously, due to students' experiences in the playground, at home, playing sport, they know the further your foot is back, the further the ball is going to go, depending if you actually hit it or not. So most of them could predict that excellent. Then when we're looking at a matchbox and an elastic band, to them, it's a complete different thing. They started becoming confused. Oh, I don't know. Oh, will the elastic band have more or less the further back you pull it? So they really enjoyed this investigation and gained a lot of experience from it. So the outcome of the lesson was for students to understand that on average, a greater force equals a greater distance or greater movement. This obviously depends. If you're measuring two different objects and you give them the same force, they're not going to move the same. So there's lots of different variables, but we wanted them to gain that main idea. We also wanted them to have a look at how friction can play a role. So that's why we had some students on the carpet and some on a smooth surface. And we wanted to be to encourage students to record and display their measurements accurately and presentable. So within the investigation, students were in groups of 3. So 3 is a controllable number. There's not too much conflict, but they can still collaborate, discuss, and help each other out. So it turned out being excellent. There are a few different approaches to showing the students. We had the demonstration with the ball, which was, again, as I said, basically the same. Some groups I actually went to and demonstrated with the matchbox because I knew they needed that more one-on-one support. Some students were able to ask a partner from another team if they required any help and I wasn't available or my mentor wasn't available. There was the video, and also people were able to, and I was able to demonstrate. Though I did stay with one group for most of the time. However, I did have roaming time where I used probing questions. And some of those were things like, oh, why do you think that teams went further at that point? Or what could we do to make everyone's even? Just getting them thinking about those different forces that are affecting the matchbox. Throughout the investigation, students predicted, they conducted, so they actually were involved in the lesson, they analysed, and we begun to evaluate. That was more of a class discussion. They are definitely, or the students were definitely not at a very good level there. And they also struggled to correctly record their metres and centimetres. So an example I have here in this student, up here they've written 1 metre 35 centimetres. This is also in my report. But down here they've written 2.15 metres. So they did understand the concept as demonstrated there, but they couldn't do it every time. So not sure if they were rushing, and that was evident in majority of the students. They couldn't do 1 point something metres. They did 1 metre this many centimetres. So obviously if I was to redo this investigation, there would be more time spent on measuring and recording data. Most students completed it correctly. They filled out their form correctly. They understood and they predicted correctly. And they also were able to connect to friction, which is excellent because I hadn't really mentioned that before. I wanted to see where they went with it. So one student said, what challenge did you experience during the investigation? And they said friction, so that's down here. And they said, how did they overcome this? They moved to a smooth floor. So that's showing their understanding that a smooth floor has less friction than a carpet as it has like rough surface. Therefore, it will move further. So that was excellent to see some students understanding that without discussion. We then got a chance to talk about it as a class. Students also had some great responses for reasoning. So some students were on the right track. A few were confused, and I think it was just their word choice, and that would involve more one-on-one discussion with that student. So for example, 2 of the good responses were because the elastic had more force as it went back. That was the explanation to why the matchbox went further. Another one was the further back the band is pulled, the more force is put onto the object. And the confused one was because when you pull it further back, more forces affect it. Now, I think that word affect should be changed for applied. So more forces are applied. So that was where I thought that student may have been confused. When planning this investigation, I wanted to use a constructivist approach. So Scamp and Preston 2015 explained that a constructivist approach is where students create their own meaning based on their own world experiences and their prior knowledge. So it's basically just throwing them into an investigation, giving them a few barriers and probing questions, and letting them investigate. So they also, Scamford Preston also demonstrated in one of their writings or reports that good learning consists of students participating in the lesson. So this could be models, it could be graphs, it could be engaging videos, it can be construction, so hands-on activities, and negotiation, also known as communication. Science is a crucial subject for students, and that was even clearer after completing this investigation. So science is everywhere in our world. Almost everything we are doing, living, breathing has to do with science. So for students to understand those concepts, it's crucial. Not only is it crucial for that reason, but as stated in Evans and Renee 2009, science helps students become informed and active citizens. It helps them make evidence-based conclusions. It helps them be able to interact with other people on a scientific level and have that bit more of knowledge. Just use that terminology that some other people might not have got the chance to learn. And it's also beneficial for our future, for these young students to be learning about science. I also learned throughout my investigation that students are very egocentric. The world revolves around them. So when they are telling you about their prior knowledge and their experiences with that topic, it will often be very egocentric. So as a teacher, and according to Roger Freiberg 1985, it is important to make your learning more student-led compared to teacher-led. Often when it's teacher-led, you're telling them, and if they're not connecting with that same idea, you're not going to get through them. So ensuring that they have that opportunity to share what they're thinking, because obviously science can be looked at in many different ways, then that's very important. Other than that, all other information can be found in my written report, and thank you for listening.